Alright, so we're getting into 7.6. We're talking about special right triangles. Specifically, we're going to talk about how you can use the ratios, specifically with 40, 45, and 45, 45, 90, and 30, 60, 90 triangles to solve some problems. These are special right triangles. You'll see them a lot, especially in the next section of 7.7. And here are some thumb rules here. 30, 69 triangles can be found using a simple equation. The short side is the square root of 3 times the long side, and the lengths of the short leg and the long side of the hypotenuse, are of a 30, 60, 90 can be found using the equation. The short leg is 2 times the hypotenuse. Right, that sounds like a bunch of gobbledygook, but maybe we'll see that with some examples up here. And then the short legs, or the lengths of the sides of the 45-45 triangle, can be found using that the leg is square root of 2 times the hypotenuse. So, that's maybe doesn't make a lot of sense right now, but hopefully it does in a second. And here's a fun fact that is also true. Like, if you have these equilateral triangles, right, if you ignore this little bisector right now, an equilateral triangle means that that all of the lengths of the line segments are the same length. It's equilateral. Lateral means it's of the same length, right? And all of these would be 60 degrees, right? Because there are 3 60-degree angles, all of the same measure, adding up to 180. Well, if I split it up in 2 directly down the middle, this would now become 2 identical. I would bisect that line, and this would become like half of one of these sides, right? And this would now split that right down the middle, so that would be 2 30-degree angles. So it would become 2 30, 60, 90-degree triangles, and this is now 1/2 of that, which is kind of cool, right? So that is something that is going to come into play tomorrow, and something you may see a lot of in problems and stuff. So that'll come in handy. Okay. So let's work through some of these things over here. You may see some similar shapes on this side, and then some similar shapes on this side. But we're going to just walk through these things, and I want you to pay attention to the ratios that get kind of spit out no matter how big the shapes are, because they look like they could be similar, right? So how do I figure out the lengths, right? So, hypotenuses take a little bit more to figure out. Right, this looks like it's, I'm just going to count these blocks because it's out here in the ether, and I have a larger chance of, figuring out lining up the points wrong than I just have counting the blocks. So this is 1, 2, 3, 4, 5. This distance is 6, right? And then this distance here is 1, 2, 3, 4, 5, 6. So this is a 6 by 6 triangle. Right? So how do I figure out these angles? So I could do 6 by 6. I could do this. I could go 6 squared plus 6 squared equals z squared. That's Pythagorean's theorem. And I could solve that, right? And figure out the length. And then do some Pythagorean's theorem with sine, cosine, and tangent, and then figure out the length with that. But I could also say, let's figure out this theta. Let me get different colors here. See this is y. This is 6. I'll use y as green. Okay, and then I'm going to say that my opposite here is theta, right? And how could what trigonometric function uses the adjacent and the opposite side. Right? Think on it for a minute. And tangent is the correct answer. Right? So if I say the tangent of theta equals opposite is my y value over adjacent, which is 6, All right, I have two unknown variables here. Oh, actually, I don't know I have two unknown variables. I know that this is 6. I counted it. So I have 6 over 6. Right, so my tangent of theta equals 1. Okay, so how do I figure out tangent with that? Or my theta with that? Right, so I go 6 divided by 6 equals 1. Right, so if I want to solve for tangent here, I go theta equals the arctangent of 1. Because it's 6 over 6 equals 1. So that's the tangent of 1, and I do the arctangent of 1. So theta equals 45. So theta equals 45. Well, if this is 45, that is 90. These two angles have to equal up to 45. Or sorry, these two angles, my leftover two angles have to equal 45. Have to equal 90. Excuse me. These two angles have to equal 90. 45 minus 90 is 45, or 45 plus 45 equals 90. So this has to equal 45. So these two angles are 45. This is a 45, 45, 90 triangle. 45, 45, 90 triangle. Okay, so, well, let's go over here and let's do the sine. Let's go do it over here, I guess. Let's do the sine of theta, right? Which was this one. So the sine of theta, which we know is 45, equals opposite, which is 6, over our z, which we don't know yet, over z. Okay, so if we want to solve for z, right, we have to say we switch z and y. Alright, so it's going to be z equals 6 divided by sine of sine of 45. Let's see, make sure that's right. Multiply both by that. It's going to be equal to 6, and then, yep, that's right, equals sine of 45. Alright, so I go sine of 45 times the sine. I'm going to invert that. Sine 45, take the sine of that. I'm going to invert that. I'm going to multiply it by 6. And so this length is going to be 8.48. And then roughly, right? But that is not, this is 8.48, and then it goes on for a lot, right? This is approximately, okay? It is not going to be as accurate as the algebraic solution could be, okay? Because this is just an approximate value, okay? It rounds off all this. It's actually 8.485. Right, that's as close as I'm gonna get. Right, three decimals is good, right? But it's still not gonna be as close as this. Okay, so let's do this math over here. Okay, so we're gonna do, we'll do 6 squared. 6 squared plus 6 squared equals z squared. 36, so 6 squared plus 6 squared equals 72. Okay. Now 72, so this is going to be equal to the square root of 72 equals z. Alright, so if I took the square root of 72, you can see that it's really close to that. In fact, it is that, but I truncated all of these numbers. So I could put the square root of 72 here. Square root of 72, but this isn't simplified. Alright, I can say that 72. What is 72? Is there any? I bet 6 is in there somewhere. Yeah, 6 is in there somewhere, but that's not cool. But how about 2? 72 divided by 2. 36. Cool. 36 is a perfect square. I can take 6 out of that, right? Because I take the perfect square. That's 6 divided by the square root of 2 equals z. And look at the coincidence there. 6 square root of 2, right? It's all the lengths of the sides times the square root of 2. That's what this is saying over here, right? It's the length of the leg, any length of the leg, times the square root of 2, right? That is all that distance. You could have done it with tangent, right? Or you could just say, oh, this is a 45-45 triangle, right? I'm just going to take the length of the leg and put square root of 2 behind it, and lo and behold, I have the length of the hypotenuse. Much easier, okay? Much easier. So this is a good one to know. Good one to know. Okay. It saved me all that work. All that work. And if I just know that thumb rule, this thumb rule, a little symbol for thumb rule, and it doesn't matter what this is. It could be like 6.745. And I could put 6.745 times the square root of 2. And that would be good. I could take the square root of 2, right, and multiply it by 6.745. Right, and then that would be the answer, right? That is the cool thing about 45, 45, 90 triangles, right? So over here, if this is 1, 2, 3, 4, 5, 6, 7, 8, this is 8. 1, 2, 3, 4, 5, 6, 7, 8. This one's 8, and this one's 8. They're equilateral sides. You know this is a 45 and a 45. It's always going to be like that. If the lengths of the sides are the same, right, always going to be 45 and 45. That means that this is 8 square root of 2. Right? This is 1, 2. This is 1, 2. This is 2 square root of 2. This is 1, 2, 3, 4. This is 1, 2, 3, 4. This is 4 square root of 2. Right? It's that simple. And if you want to check the math on me on that one, go ahead. Right? But that is why this one is so cool. Super simple. Really, really easy. You just slap square root of 2 on the behind whatever the lengths of one of the legs are, because the lengths of both the legs are the same. Okay? So that is the special triangle 45, 45, 90. My favorite, because it's so simple. Alright. Because it's always going to end up being whatever is inside this radical here, right? Because you're just going to end up doubling the square, and you're going to take out that double every time. It's going to work out every time, right? Say it's 4. 4 squared plus 4 squared, that's going to be 16 plus 16. 16 plus 16 equals 32. 32 divided by 2 is 16. I'm going to take out the 4. Square root of 2. See? Every time. Every time that pattern works out. Mathematically, it's always going to be the same. Alright, so now let's move on to the 2 rules for the 30, 60, 90. Well, the 90s is in there, okay? You might as well just say there's 30, 60, right? Now, why are there 2 rules? Well, there are 2 different angles, a 30 and a 90, and they're kind of like reciprocals of each other, okay? So, if I have let's do this one out here, and I'm out in the middle of no man's land. Okay, my x value is 1, 2, 3, 4, 5, 6, 7, 8. And my y value is 1, 2, 3, 4. Imagine that. It's a 2 to 1 ratio. 4 to 2 to 1 ratio. Okay? So, let's see over here. Is that the same thing over here? Wait, is it a 2 to 1? It's 1, 2, 3, 4, 5, 6, 7. No, it's not quite a 2 to 1. Excuse me. This is 7. It's not 2 to 1. Sorry about that. That sounded funny when I said it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4. Yeah, right, because it's 8 to 12 is 4. And 14 to 7 is 7. So yeah, count your coordinates. Alright, so say we're doing theta here. This is obviously the 30-degree angle, and this is in here is the 60-degree angle. Right, so how would we figure out theta here? Right, or how do we figure out the hypotenuse? Right, we're going to test out the short leg is square root of 3 of the long leg. Okay, or square root of 3 times the short leg is the long leg. And this was saying the short leg of this one's saying that the hypotenuse is 2 times the short leg. Okay, so well, what are trigonometric functions can we use to test these theories? Right. Well, so this one is saying that the short leg is 3 times the square root of 3 times the long leg. So this is what sorry, you can't see. What in reference to theta uses the long leg and the short leg? Well, that is tangent, right? So the tangent of theta equals 4 divided by 7. Okay, so if I wanted to figure out the ratio there of the tangent of theta, right, is going to be what am I trying to prove? Square root of 3 times the long leg. Well, what is the ratio of the long leg to the short leg? Okay, so if I go, this actually I don't even need to use tangent, right? It's just the ratio of 7 divided by 4, right? 7 divided by 4 is 1.75. What is the square root of 3? 1.73. So 7 divided, I said 7 divided by 4, sorry, 1.75. Short leg, square root of 3 times the long leg. 4 times. Maybe this isn't exactly 7. That could be the issue. Square root of 3. Square root of 3. Square root of 4. Square root of 3 times 4. Yeah, it's actually 6.9 if you look real close. If you look real close. Not exactly there on 7. It's actually about 6.9. But it's absolutely 4 there. Absolutely 4. So this is about 6.9. And this is 4. Right. But either way, if I wanted to say here that this was 4 times the square root of 3, this would be about square root of 3 is 1.732. Well, you can't see anything. Hold on, let me back that out. Alright, so if I took square root of 3, I multiplied it by 4, right, this would be a 6.92, and that's pretty close, right? You can't really put 2.28 on there. Right, so the inverse tangent. So if I wanted to figure out what this length was, right, and I was given that this was a 30-degree angle, right? So how would I figure out what this length was? All right, so here's a better example there. All right, so I would figure out the inverse tangent, or the tangent of 30 equals 4 divided by my x value, which is supposed to be blue, right? That was supposed to be blue. My x value, right? So I have to solve for x. X equals 4 divided by, multiply both by x, and then divide, so that would be divided by the tangent of 30. Okay, so the tangent, 30 tangent equals that, and that makes sense. So 4 divided by 30 tangent equals, and that would be 6, and that, there it goes, our 6.92. Approximately 6.92. 6.992, or you could say it is 4 times the square root of 3, right? Because this is 4 times the short leg, because if you go 4 times the square root of 3 is that, right? So if I wanted to figure out, if I knew that the short leg here, well, I don't know the short leg, it's somewhere in the middle, but the long leg here is 9, or is 8. The long leg here is 8. And in order to get the long leg is 8. Long leg is 8. And I know that the short leg equals the long leg times 3, square root of 3. Okay, that means in order to get the short leg, I would have to divide short leg by square root of 3 to get long leg, right? So this would be 8 divided by square root of 3. But we don't like to keep square root of 3's on the bottom, any radicals on the bottom. So we have to multiply square root of 3 by square root of 3. This would be 8 square root of 3 times 3, right? So this length here, sorry, this was 8. Oh, we're trying to find the short leg, aren't we? Oops. Our long leg, all wrong. This is all wrong. Our long leg was 8. Alright, so our long leg equals square root of 3 times our short leg. Right, so our short leg equals our long leg divided by square root of 3. This is still the same thing. Right, so our short leg would be equal to 8 divided by square root of 3, which is going to be equal to 8 square root of 3 over 3. So this is going to be equal to 8 square root of 3 over 3, which equals 8 times 3 square root equals divided by 3 equals about 4.612, approximately 4.612. Okay, so that's the relationship there. Okay. Okay, so that is the long leg versus the short leg relationship. Okay, now we have the hypotenuse. Okay, so if you just remember that the long leg is square root of 3 times the short leg. Okay, and square root of 3 is about 1.34 longer. About 34% longer, if you want to remember it that way. Okay, because square root of 3 is, 73% longer. About 73% longer than the long leg. Well, yeah, in a 30-degree triangle. Okay. So then the hypotenuse is easy. It's the short leg. It's double the short leg, right? So if our short leg here was 4, then our hypotenuse is 8. Right? Our short leg here is 7. Our hypotenuse is 14. Right? So that's how all that works over here. Okay? So that is some stuff here that should be able to help you out. Let's see if we can do some problems here. So let's write up some things to help us remind us. 30, 60, 90 triangle. Okay, this is, we're gonna, whoops, you can't see that. We're gonna call this X. We'll call this Y. We'll call this Z. All right, Z equals what? 2x. Right? Z equals 2x. And what does Y equal? Or X equals? X equals square root of 3 is Y equals Y times the square root of 3. If you can remember that. Okay, and then our 45, 45, 45, 45s. For our 45s, this is effectively X and X, right? Because they're the same thing. We'll call them A and A, not to confuse them. It's just A and A, right? They're the same value. And then our Z value. Okay, so what was our rule for that one? It was Z equals A times square root of 2. Those are the things that we need to try to remember. Okay? So we're going to be given all these different things here. And we'll solve this one here just to start off with. We know that BE here equals 12. And that's all we know. And we'll see if we can get going here. So, are all equilateral, right? So all the triangles marked ABC are all equilateral. Determine all the line measures and all line segments, right? So if these are all equilateral, and this was 12, okay? So that means that these were all the same measure, and this is a 60, these are now 60, 30 triangles. All right, so this is a 30-degree angle, and this is a 30-degree angle. Okay, so we're getting somewhere there. So if this is a 30-degree angle, and this is a 30-degree angle, that means that this is my X of this. This is my X of that. Okay, so if this is my X of that, and what can I say about my Y? Well, I can now say that my Y is going to be 12 divided by the square root of 3. Because this is a 30, 60, 90 triangle. Right? Because this is the short edge. So 12 divided by the square root. Each one of these lengths is going to be 12 divided by the square root of 3. Multiply each one of those by the square root of 3. 12 square root of 3. That's going to be 3. Okay, so that's what that looks like now. So now that's going to be 4 square root of 3. So each one of these lengths are going to be 4 square root of 3. Okay. So, and then that means also that the z is going to be 2 of my x's. Well, actually, this is going to be 2. This is my short lengths. I think I got these backwards. My short lengths. I should change these to x and y. Oops. This is my short length. This is my long length. Yeah, that's why I'm going to do that. Okay. So, z equals 2 of my short lengths. Okay, so that means this is going to be, these are my short lengths, short length, and then short length equals square root of 3 of my long lengths. Okay, so my short lengths are still correct. This is still 4 square root of 3, 4 square root of 3. And then these are going to be 2 times my short lengths. This should be blue. That's my long length. Okay, so this is going to be 2 times. It's going to be 8 square root of 3. This will be 8 square root of 3. Awesome. That's the whole length there for these two. Okay, so now I know that this, so what can I do to figure out this here? Got this little guy here. Pause this and think about it just for a minute. Ah, yes, of course. So, whoops. Sorry, dog. So, I know that this angle here is 60 degrees. So this angle must be 30 degrees. And so I know that this length here is 4 square root of 3. So I can use, let's see, we can use opposite over adjacent to figure out this length. Or opposite over, yeah. We can use opposite over, so the tangent, I'll do it right here, I guess. The tangent of 30 is call this, and we'll just call AD. Tangent 30 equals AD over 4 square root of 3. So AD equals tangent 30 over 4 square root of 3. Okay, so tangent of 30, 30 tangent, divided by opposite over adjacent. Divided by 4 times 0.25. That doesn't seem like it's right. Let me try doing this length here. This length would be, this is the hypotenuse. Oh, that's a hypotenuse. That's why it doesn't make sense. All right, so that's the hypotenuse of this triangle. Okay, so this would be the, we'll do this one. That's going to be the adjacent over hypotenuse, which would be the cosine theta of 60 equals x over 4 square root of 3. That makes more sense. Okay, so this would be x equals, let's see, x equals 4 square root of 3 times the cosine of 60. 4 times, let's see, cosine of 60 times 4 times 3 square root equals, that's going to be, well, what was that? Hold on. 60 cosine is 0.5. So whatever I'm going to write is going to be over 2. Okay. Oh, it's going to be 4 square root of 3 over 2. So it's going to be half of that, which makes sense, right? That's 4 square root of 3 over 2, so it's actually 2 square root of 2. This is 30, 60, 90 triangle. 2 square root of 3. So that's that, which makes lots of sense. All right, so then if I want to figure out this length here, this is going to be opposite over hypotenuse, so this would be the sine of 30 equals actually I just need to do, yeah, it's just going to be a sine of 30. It's going to be, and I just need to do a, oh, that's the cosine. I need cosine of 30. Cosine of 30. Cosine of 30. So 30 cosine. 30 cosine. And it's going to be, invert that and multiply it by 2 times 3 square root. That's going to be, well, I can think about this a little more logically. This is a 30, 60, 90 triangle, so which one of these match? So this is the long leg, so this is going to be the square root of 3, the short leg. So the short leg is 2 square root of 3, so I can just multiply, well actually it's just the long leg is the short leg times the square root of 3. So this is going to be 2 times the square root of 3, which is 2 times the square root of 3, so this is going to be 6. That's just going to be 6. That's cool. Alright, so that was interesting and fun to do, actually. I like that one. So you can see how that kind of smashes all together and makes you use your brain and use these really, really handy things, which is much easier than trying to use your calculator if you just know how to use these rules here. So let you guys go ahead and try the rest of these. and I'll be a little bit more proficient in the classroom when I give this lecture. But hope you guys have a wonderful time working on these things. I think it's lots of fun.